This is a video on the acids and bases and salts and what we need to know about them in the course. The first thing I'd like you to think about really is that these are like families, and the acid family has HCl, which is hydrochloric acid, HNO3, which is nitric, and H2SO4, which is sulfuric. Sometimes the modern way of spelling sulfuric is with an F, so it's exactly the same thing. Now, the key thing to say about these acids is that they all, by being acids, are capable of donating H plus ions. Okay? An acid is something which is capable of giving H plus ions. And the way that this works is that the H plus ion and the Cl minus ion, which are bound together, when they go into water, go into the H plus ions, which are free, and that makes it acidic. The H plus ion and the NO3 minus ion are bound together, but in water will go to free up the H plus ions, which make it acid. The H2SO4, the H plus ions and the SO4 2 minus ions, that's why we've got two of them, go in water to create the H plus ions, which are free to make things acid. So an acid must have hydrogen in, because it needs to make hydrogen ions. So the H in HCl, the H in HNO3, and the H2 in H2SO4. Now, you need to know these acids, and it really is just a case of making sure that you know those three acids. HCl, hydrochloric acid, we've met in the stomach, in biology, but you've just got to make sure you know this family. HCl, HNO3, and H2SO4. Now, bases are things which are capable of donating hydroxide ions, and the hydroxide ion is the OH minus. And they, H plus ion and the hydroxide ion, are equal and opposite to each other. They cancel each other out, and that's what a neutralization reaction is. And so the base family tends to be metal oxides and metal hydroxides. And once again, it's just something we need to learn. And those are capable, so let's have an example as NaOH. NaOH is an Na plus and an OH minus, and when added to water can donate the OH minus ion in a similar way that this acid can donate the H plus. Remember that these compounds are ionically bonded here, the plus and minus, but when they're in NaOH, for example, a powder, there's no net charge, but you can dissociate this, you split it up into its ions when you add water. The reason for this is that when you add water to this, the water is able to get in, and almost like a temptress, tempting each other away, you get Na plus on its own and OH minus, and water surrounds them and pulls them apart, and therefore allows them to become available to react. Okay? So water kind of gets in there and separates them, and that's what it actually does to these as well. Water gets in and breaks up the hydrogen ions and the SO4 2 minus ions. Okay? And so one thing to say is here, these metal oxides and metal hydroxides are alkalis if they're soluble in water. Okay? So if you have, and for example, sodium hydroxide is soluble, so therefore it's an alkali. Okay? But classically, you might have copper oxide as a base. You might have, as I said, sodium hydroxide. Okay? Now, the salts. Now, salts are made when you react an acid and base together. And I talked in the lesson about a swap and change and rearrange. And what I'm going to do is I'm just going to get rid of these. I'd just like you to think about a reaction here. Imagine if we had HCl plus CuO. This would go to CuCl2 plus H2O. And this is a salt. And salts are chlorides, sulfates, and nitrates of metals. And it's important to see that they will be made by an acid, like one of these, reacting with a base, and the metal taking either the SO4 to make a sulfate, or the metal taking the NO3 to make a nitrate, or the metal taking the Cl to make a chloride. And the end result, if you cancel these out, are nothing can be created here. So we've got to have hydrogen, chlorine, copper and oxygen on this side. And so if we look at this, if we make CuCl, we're left with H and O, and it forms H2O. And in fact, if we were to balance that, 2 hydrogens, 1 copper, 2 chlorines, and that's balanced. Okay? So the reactions that we need to know are, and if we just quickly go through them, we need to know that an acid, so let's say HCl is in double again, plus a base, CuO, goes to a salt, CuCl2, plus H2O. That is acid plus base goes to salt plus water. Now we need to know that. We also need to know another one, and that is that an acid plus a reactive metal, so HCl plus, let's say, sodium, goes to NaCl plus H2. And in this situation, 2, 2, 2, we have formed a salt, which is a chloride of sodium, and with a metal, remember, with a base it formed water, but there's no oxygen here, so it just forms hydrogen gas. Okay? And so we once again need to learn acid plus a reactive metal goes to salt plus hydrogen. So, just to recap, acid, and it could be any of these acids, plus metal goes to salt plus hydrogen. Here, the salt being made is a chloride because it's hydrochloric acid. If we were to use H2SO4, it would go to a sulfate, which would be Na2SO4. So the salt that's made always takes the suffix, the anion, which is bound to the cation. The hydrogen is a cation, and the anion is the negative ion. It always takes the negative one. So you can work out the salt from the acid that was used in the first place, and with a reactive metal, they always produce hydrogen. So acid plus base goes to salt plus water, and acid plus reactive metal, of which you should know them, certainly the ones in group 1 and a number in group 2, like calcium, will go to a salt that is derived, which is taken from the negative ion of the acid plus hydrogen. And they are two of the main areas, as well as the families, that we need to know for this part of the course.